దూరవిద్యా విధానంలో డాక్టర్ బిఆర్ అంబేద్కర్ ఓపెన్ యూనివర్సిటీ దేశంలోనే మొట్టమొదటి సార్వత్రిక విశ్వవిద్యాలయం. దాదాపు 2.5 దశాబ్దాలుగా దూరవిద్యా విధానం ద్వారా కంప్యూటర్ కోర్సును అనుసంధానం చేస్తూ BA, BCom, BSc డిగ్రీ కోర్సులను అందిస్తోంది. పోస్ట్ గ్రాడ్యుయేషన్ స్థాయి, డిగ్రీ, డిప్లొమా స్థాయి కోర్సులను ఔత్సాహికులైన విద్యార్థులకు అందిస్తోంది. డాక్టర్ బిఆర్ అంబేద్కర్ సార్వత్రిక విశ్వవిద్యాలయం స్థానికంగా స్వయం బోధనా పద్ధతిలో ముద్రణ రూపంలో రూపొందించిన కోర్స్ మెటీరియల్ అందిస్తోంది. కోర్స్ మెటీరియల్ అధ్యయనానికి సహకరించే విధంగా రేడియో, టెలివిజన్ పాఠ్యాంశాల ఆధారంగా కార్యక్రమాలు ప్రసారం చేస్తోంది. అధ్యయన కేంద్రాల ద్వారా ఏర్పాటు చేసే సలహా సంసర్గ తరగతులు, సైన్స్ ప్రాక్టికల్ సౌకర్యాలు విద్యార్థులకు స్వయం అధ్యయనానికి ఒక చక్కటి అవకాశం. ఇవి విద్యార్థి సమీపంలో ఉండే అధ్యయన కేంద్రం నుంచే పొందొచ్చు.
Welcome to students. Today we are heartily welcome to teleconference of Dr. B.R. Ambedkar Open University. Today we are discussing about curve tracing. It is a part of differential calculus UG first year BSc Mathematics semester 1. So in this program, first 40 minutes the two subject experts will explain the curve tracing, and last 20 minutes the concerned students they should call the following telephone numbers to clarify their doubts. I am giving the following telephone numbers. Note down: 040-270-31431, 040-270-31432, 040-270-31433. Today in this curve tracing topic we are discussing about what is a curve tracing, what is a Cartesian equation, parametric equation, polar coordinates, polar forms. All these topics should be covered in this teleconference, as well as it is very useful to the coming examinations of this semester in the month of March 2018. Before starting the teleconference, I would like to introduce the two subject experts sitting here. Professor Vedanabatla Srinivas Garu, Professor of Mathematics, Dr. B.R. Ambedkar Open University. Another one, Dr.K.V. Vijaya Lakshmi Garu, HOD, Department of Mathematics, Loyola Academy, Secunderabad. Srinivas sir, what is the useful law of curve tracing? What is how the students should be learn? What is the parametric? What is the range? What is the before in intermediate what they would study, and how it is useful to the UG first year student? Please explain to our students.
Thank you, Dr. Vijay. Good afternoon, students and counselors. The topic of today's program is curve tracing. This curve tracing is not a new topic. You have been studying this in your high school to some extent. In fact, in your high school education, you have learned to draw the graph of a straight line, of a general straight line. Drawing graph of a straight line means curve tracing or curve sketching. Here by graph we mean, if you are given a function f of x, by graph we mean the set of points that is ordered space x comma f of x, where x varies over the domain of f. So if you are given a function, you will look at the points x comma f of x, and that set of points gives us a curve. That's what we mean by curve tracing. Well, in fact, the trivial most function is the constant function. If you are given y is identical equal to constant c, then you know that its graph becomes a horizontal line. That is x-axis you have, and the horizontal line passes through the point 0 comma c. It's a line parallel to the x-axis. It is the graph of the trivial most function, the constant function f of x identically equal to c, where x varies over the entire real line. And in general, if you are given a first degree linear equation, you have y equal to mx plus c. you know that it is the equation of a straight line, and in fact you have drawn its curve or graph as a straight line passing to the point 0 comma c with slope m. Okay, and this you did in your high school, and in your intermediate or +2 you have studied conics. What are conics? Conics are the plane sections of cone. You take a 2-sheet cone and then cut a cone with madam, you may show slide, and you can cut a cone with a plane. The plane sections of a cone are conics. What are conics? They are circle, ellipse, parabola and hyperbola. So you get broadly three kinds of conics, and well, you have learned the theory of these conics in your +2 and intermediate. In today's lesson, you will learn how to draw their graphs. Okay, and in fact, any curve in the plane, in the xy plane, is called a plane curve. And today, our lesson will tell you how to draw the curve of a function if you are given the equation of a function. Okay, in fact, this process involves 9 important steps. These are like navagrahas for us. These 9 steps involve the extent of the function, and then the symmetry with respect to a line, and then the continuity, differentiability, and then you also discuss the second derivative of the function, and then we discuss the points of inflection, and then we look at singular points, and we also look into asymptotes. The knowledge of all these 9 steps will enable us to draw the equation to draw the curve of a general function in xy variables. Okay, in fact, let's look at a few popular examples of plane curves. We have the ECG. ECG is a plane curve. For example, in this ECG you have 4 horizontal curves, 4 curves. So these 4 are plane curves, right? And also you have the frequency curve. You know drawing histograms, and the midpoints of the widths of the histograms, those will be joined with a smooth curve. You get a frequency curve. A frequency curve is a plane curve. It is a curve in the xy plane. And your another popular example is the Stokes curve. You take Stokes along a time period or a certain time period, and then you take Stokes in the y-axis. You get a curve, the Stokes curve. Daily we see in our news the Stokes curves. We also have the score curves. You have the vowels along x-axis and runs made along y-axis. You get score curves. This we see in the game of cricket. So plane curves are very popular curves. So today we will learn the so-called navagrahas for us. These are the 9 steps. So first we learn these 9 steps in about 40 minutes, and after that we move these. In fact, these x and y are called rectangular coordinates or Cartesian coordinates, and then we move to the parametric form of equations, and then we move to polar coordinates. Now I pass on the lesson to Dr. Vijaya. Dr. Vijaya.
Good afternoon, students. A picture tells 1,000 words. A function, a curve which in visual version of a functional relation will give us so much of information. As sir told, a graph means the set of all points x comma f of x. Suppose you have a functional relation f of xy equal to 0, the set of all points xy such that f of xy equal to 0 is called the graph of the functional relation f of xy equal to 0. Drawing a graph of a relation, we mean plotting the points on the line. But however, it is not possible always to plot all the points. So that is the reason today we are going to discuss about a standard techniques to plot a graph of the curve by coordinating tangents, asymptotes, singular points and symmetry over the origin or lines, etc. So, today and after that we will draw a final curve, but always whatever the graphs we are drawing, always they cannot be or they need not be complete. Why? Because the variables x and y, always they are not finite. If x and y are finite, we can get a complete graph. If x and y are infinite, we can't get a complete graph. Just one simple example, if you take y is equal to f of x or f of x is c, a constant function which is a line parallel to x axis, but it has no ends because x axis is not finite line. So, that is the reason now we will take up the tracing of a curve when it is given in the Cartesian form. So, as a step 1, first I am going to step 1, sir. As a step 1, we determine the extent of curve. What do you mean by extent of curve? Suppose if I take y square is equal to x. Y square equal to x is a parabola, that is always y square is equal to x means x is always positive. X is the positive means always the curve lies in the positive part of x axis.
Now
First, that is the first step.
Yes, ma'am.
But
Second,
always
please
to
explain.
find step 1, that is suppose if you want to find the extent of the curve, explicitly we write the function as y is equal to f of x or x is equal to f of y.
And this extent also involves the range
Yes,
of the
sir.
function.
Mm.
So, if we know the range of the function,
Yeah.
that helps us to locate the points on the graph.
Yeah.
And also we locate the complement of the range also.
Yes, sir.
We determine the complement of the range also.
So,
that
yes,
will
sir.
give where our curve does not pass through,
Does
where
not.
our curve does
Yeah.
not sit in.
Yes, yes.
Okay. So, determining the extent is very important to draw the
Yes.
curve. And in fact, in the next step, we move to symmetry. So,
Symmetry.
Madam,
Yeah.
can you talk about
First, as step 2, after finding the extent of curve by writing the curve x equal to f of y or y is equal to f of x, if you take x equal to y square or y is equal to x square, no, y is equal to x square means always it is positive. So, no part of the curve lies in the third and fourth quadrant, always it lies on the positive part of a y axis.
Yes.
And then suppose next as a step 2 we go for symmetry. Symmetric means first we will see whether it is symmetric about x axis or y axis or both the axis, or it is symmetric about the line y is equal to x. So, first let us discuss one by one. When we say that symmetric curve is symmetric about y axis, when all the powers of x are even. That means if you replace in the curve equation f of x y equal to 0, replace x by minus x, then you will get the f of x y equal to 0.
0.
That means if powers of x are even, curve is symmetric to y axis, y are even, curve is symmetric to x axis.
X.
And suppose a curve is symmetric about a line, when if you fold the curve along the line, definitely the two parts of the curve superimpose. And we say that curve is symmetric about origin. If you rotate about 180 degrees, we will get the curve. No need to draw curve, entire curve. If you draw the curve in the first part, it is enough.
F of x comma y, f of x comma y is equal to f of minus x comma minus y.
Y.
So,
Yes.
if it is a 180 degrees. What is the possibility, madam? What is the possibility and what is the extension to the student of the curve it will be taken?
That means he will draw the curve in the upper half of the
Yes.
x axis, upper half of the plane.
X axis.
X axis, it is enough. And suppose if you replace f of x y equal to f of y x, that means if you replace the positions, suppose if you take the curve x cube plus y cube is equal to 3a xy. If you take the curve x cube plus y cube is equal to 3a xy, if you replace x with y and y with x also, equation will not change. So, in that case we say that the curve is symmetrical about the line y equal to x. And if you
Madam,
take
when you were saying that the curve is symmetric with respect to the y axis, we can as well say that the function is even, right?
yes,
f of x is f of minus x.
Yes.
So for all x,
Yes.
if that is the case, then the function will be symmetric with respect to
Yes.
the y-axis.
Yes.
Okay, madam. And how about symmetry with respect to the origin?
Symmetry about origin, if you take the equation of the circle x square plus y square is equal to r square, that means both the powers of x and y are even. That means if f of x y is the same as f of minus x comma minus y.
Means in the equation of the curve,
Yeah.
if we replace the points x comma y, the coordinates x comma y by minus x and minus y, and if we get back the same equation,
Yes.
same equation means these two equations are equal. Means f of x comma y equal to 0 if and only if f of minus x minus y equal to 0
Yes.
for all x comma
Yes,
y.
yes.
Then we say that function is symmetric with respect to the origin.
Yes.
And this concept is same as rotating the graph. First we move, as you said, we draw the graph in the upper half plane. Then it is first enough to draw the graph in the upper half plane, that is above the x-axis. And because if our function is symmetric with respect to the origin, we draw the graph in the upper half plane, and then we rotate the graph by 180 degrees
180
and
degrees.
get the remaining part of the graph, and we took these two parts together, the
Yes.
parts in the upper half plane and the lower half plane together give us the graph of the function. This is the case when we deal with the functions which are symmetric with respect to the origin.
Suppose if we take
Can
the
you
curve
show
y
some,
equal to x
some
cube,
videos
it is
like
not coming.
skipping? I see.
It is not coming.
Well,
So if you take the curve y equal to x cube, suppose in that case if you have minus y is equal to minus x whole cube. So in that case you have f of x y is 0 as well as f of minus x comma minus y also is 0. So
Yes.
that curve is symmetric about origin.
Origin.
So in that way we can
so
check.
and we also have, if x is greater than or equal to 0, x cube becomes greater than or equal to 0. Means y equal to x cube is greater than or equal to 0. So in the first quadrant we have some part of the curve.
Yes.
And this
Anyhow, by rotating you get in the opposite quadrant also curve.
yeah, this y equal to x cube is symmetric with respect to origin. So first we draw the graph in the first quadrant, and then we get by rotating it by 180 degrees we get the graph in the third quadrant. These
Yes.
two parts together give us the graph of the function y equal to x cube. Well,
Next, let us move on to step 3. So actually first we have find out the extent of the curve, and the second one we discussed about symmetry, all the symmetry, when it is symmetric about y-axis, x-axis, about the line y equal to x. After that we find the points where the tangents are parallel to the coordinate axis. That means, or we will find the points where the curve crosses the axis.
Slideshow.
That means put y equal to 0 in the equation to get points on x-axis. Put x equal to 0 to get the point on y-axis. And after that, after getting the points on x and y-axis, we will get ranges for x and y. And then we will see where the function is discontinuous as step 4. And after that, we move on to the step 5.
do you have any slides, madam, to show?
Yes, the slide is there.
Like the
Yeah.
hard copy slides, if you have, you may show them.
Yeah.
There is some technical problem. Okay, with this thing.
Hard copy.
Well, we are talking about the symmetry of a curve with respect to both x and y coordinate axes. For example, if we take a
Look
circle,
at this. Yeah.
so if we
Like bit.
if we so if we take this circle x
Yeah.
square plus y square equal to r square, then that circle is symmetric with respect to origin.
Yes.
Madam, can you show this graph of the circle x square plus y square equal to r square for symmetry with respect to x and y axis? I am talking about symmetry, the step 2. So if you consider the equation x square plus y square equal to r square,
Yes.
that is equation of the circle centered at the origin of radius r units. And now in this equation x square plus y square equal to r square, we have the even powers of x. All the terms involving x have even powers. Similarly, all the terms of y are in even powers.
Yes.
Therefore, this
Yes.
curve will be symmetric with respect to both the coordinate axis, x-axis and y-axis. Now, it is enough to draw the circle in the first quadrant, and first we draw the circle in the first quadrant, and then because this is symmetric with respect to the y-axis, we take its reflection in the y-axis, we get the graph in the second quadrant. And then because this is symmetric, the graph is symmetric with respect to x-axis also. I am talking about the circle, madam.
Yes.
Because this graph is symmetric with respect to the x-axis, we take its image in the x-axis. We get the reflection, and that reflection gives the part of the curve in the lower half plane. So these all the graph parts in the 4 quadrants give us the graph of the function x square plus y square equal to r square.
R square, yes. Now let us move on to step 5. For this, as the step 5, we calculate dy by dx.
How about continuity, madam? Can we say something about continuity of a function?
We will check where the function is discontinuous after finding the put y equal to 0 in the equation to get points on x axis and x equal to 0 to get point on y axis. So after that we will locate the points where the function is not continuous, and after that we move on to finding dy by dx.
Even madam, let's
Yes.
talk something about continuity.
In our Telugu medium students also, in this function ప్రమేయం అవిచ్ఛిన్నం అనే బిందువులను కూడా మనం గుర్తించాల్సి ఉంటుంది. x అక్షాన్ని y అక్షం మీద మనం గుర్తించినట్లయితే దాని తర్వాత మనం శ్రీనివాస్ సార్ చెప్పినట్టుగా dy by dx d square y by dx square ని మనం చేస్తాం. మేడం ప్లీజ్ కంటిన్యూ.
First
Madam,
we will find dy
I will
by
speak
dx.
something on continuity.
Yes.
Right. Actually, our students belong to both the media, English and Telugu. That's why sometimes we may speak in Telugu also. Well, let's talk a little more about continuity. By roughly speaking, to draw a continuous function on an interval, we don't need to lift the graph of the pencil when we draw. That is a vague way of putting a continuous function. Okay, and for example, if you take the unit impulse function, that is discontinuous at the point x equal to 0. On the negative x-axis, you have f of x equal to 0, and when x is greater than 0, if your y is 1. So if x is greater than 0, y is completely 1, and if x is less than 0, y is completely 0. That is the unit impulse function.
Yes.
That is called unit. That is a step function. Okay, and this is discontinuous at x equal to 0. So you have a jump when you draw its graph. You have a jump at x equal to 0. So in that case, you have to lift your pencil and draw the graph. So when you draw the function, you must concentrate on continuity also. And for example, if you take the integral part function,
Yes.
integral part function is a step function. The graph will be like steps, right? And for that integral part function, you have discontinuities at every integer. In fact, the integers are the only points where that function, integral part function, is discontinuous. By integral part function, x, box x, we say it is the highest integer smaller than or equal to x when x is any real number. That is the integral part function. Okay, madam. Now can we move to
Find dy by
differentiability?
dx. Next step 5. After finding dy by dx, this help us in locating the portions where the curve is rising or falling, or the points where it has a corner. That means if dy by dx may be greater than 0 or less than 0. After finding that equal to 0 means points are some stationary. And next we move on to finding d square y by dx
Madam,
square.
Actually, derivative.
Yes.
What is? Let's say something about the geometric importance of derivative.
Yes.
Derivative is geometrically slope of tangent.
Slope of tangent.
For example, one popular example is mod x function, the absolute value function. It is in the shape of v.
Yes.
Right? If x is positive, you have y equal to x in the first quadrant, and if x is negative, you have y equal to minus x in the second quadrant. The graph of the function y equal to mod x is in the shape of v. And at x equal to 0, this function is not differentiable, because you can see from the definition of derivative that the right hand derivative at x equal to 0 is plus 1, and the left hand derivative at x equal to 0 is minus 1 for the absolute value function, that is the modulus function. So modulus function is not differentiable at the origin, that at x equal to 0. So it is because the function has a sharp turn, sharp corner. So whenever a function has sharp corners or takes a sharp turn at those points, we can expect for the derivative to fail, not to exist. So whenever the curve, if the curve is like the teeth of a saw, at those points the curve is not differentiable. If the graph of the curve is the teeth of a saw, then a carpenter's saw, then at those points where it takes sharp turn, then the function fails to be differentiable. Of course, such a function is continuous. Now,
after finding dy by dx, we will find d square y by dx square, and we know that d square y by dx square, whenever it is less than 0, we will have maximum at that point, and d square y by dx square greater than 0, we will have a minimum at the point. At the same time,
in fact,
we
will
be able to for local maxima and minima,
yes.
and also we will be able to locate the points of inflection. As we know, inflection points are where the function changes concavity to convexity. That means, since the concave up corresponds to a positive second derivative and concave down corresponds to a negative second derivative, then when the function changes from concave up to concave down, the second derivative must be equal to 0 at that point. However, but f double dash c equal to 0 is not a necessary condition to have a point of inflection there. Why? For example, if you see the function, if f of x is equal to x into mod x, we know that f of x equal to x square if x greater than or equal to 0, equal to minus x square when x less than 0. That means your f dash x is 2x when x greater than or equal to 0, minus 2x if x less than 0. At the same time, f double dash x is 2 if x greater than 0 and equal to minus 2 when x less than 0. There we get point of inflection, but here your f double dash c at 0 is not equal to 0. Here f double dash 2 is not equal to 0. So what I say is, here f double dash c equal to 0 is not a necessary condition to have a point of inflection at that point.
అంటే అంత్య బిందువులు లేవని మనకు తెలుస్తుంది. d స్క్వేర్ బై dx స్క్వేర్ 0 లో మనకు అంత్య బిందువులు లేవని తెలుస్తుంది. గ్రేటర్ దాన్ 0 ఉన్నప్పుడు x గ్రేటర్ దాన్ 0 అవుతుంది, లెస్ దాన్ 0 ఉన్నప్పుడు x less than 0 అవుతుంది.
In fact, madam was speaking about points of inflection.
Points of inflection.
For example, a curve simpler than that
x into mod x.
X mod x.
X mod
is y equal to x square.
Yeah, y equal to x square.
The parabola y equal to x square. It is symmetric with respect to the y equal to x square. It is symmetric with respect to y axis, so first in the first quadrant, if we see, you have the parabola like this. So y equal to x square, and its derivative is 2x when x is positive.
Yes,
okay, and its second derivative is 2. That is positive. So if the second derivative 2, the curve is like this, so it becomes convex.
Yes, sir.
Okay, and if you look at when your x is negative, that is when you look at the graph in the second quadrant, the graph is like this. Okay, and so it is y equal to x square. First derivative is y dash, that is 2x, and that is negative, and the second derivative is y double dash. It is how much? Y is equal to x square.
dy by dx is 2x.
Yeah,
d square y by 2 is positive.
Y dash is 2x, y double dash is 2.
Also 2.
So second derivative is also the positive. So it is not changing sign.
Yes.
So the second derivative is not changing sign at the origin. So we don't have a point of inflection
for
there.
that.
And I think y equal to x cube also helps us.
Yes.
Yes.
Y equal to, next in coming sections we will discuss. Next step 7, we discuss about asymptotes. Asymptote means a tangent which touches the curve at infinity. That means here, and we say that asymptotes parallel to x axis are called horizontal asymptotes, and those which are parallel to y axis are called vertical asymptotes, and those which are neither parallel to x axis nor to y axis are called oblique asymptotes. Now we will spend some time on this asymptotes. For example, if you consider a rectangular hyperbola xy equal to c, how to find an asymptote? Rectangular hyperbola.
Repeat the definition of asymptote. Can I say like this? I take a point p x comma y on the curve.
Yes, sir.
And then I take it, and if I expect a line y equal to mx plus c as an asymptote,
yes.
I look at the distance of the point of this distance of the point from this line,
Yes.
right? And if that perpendicular distance, as limit x goes to an extended real number a goes to 0, then we say that line is an asymptote.
Yes.
And a is an extended real number, we mean it is plus infinity or minus infinity or is a real number.
Yes.
Okay, so that is the basic definition of an asymptote.
Asymptote.
It is limit of the distance of a general point to the line. If that limit as x goes to a is 0, then we say such a line is an asymptote. Now, can we look at some examples?
Yeah. If you consider a rectangular hyperbola, the equation xy equal to c, it implies y is equal to c by x. And this implies that as x tends to plus or minus infinity, we know that y tends to 0, and this mod y is the distance of a point pxy on the hyperbola from x axis. What does it mean? This means that x axis is the asymptote of the hyperbola. Similarly, we can write x equal to c by y also, and similar logic applies as y axis is also an asymptote to hyperbola.
So,
I am generalizing this condition. Yes. How to generalize this condition? A straight line y equal to c is an asymptote of a curve f of xy is equal to 0 if and only if y minus c is a factor of the coefficient of the highest power of x in f of xy. Asymptotes parallel to the x axis are obtained by equating to 0 the real linear factors of the coefficient of highest power of x in the equation of the curve.
Function f of x comma y is a polynomial.
Yeah, implicit function of x and y. Now, as an example, just I want to discuss one small example. Suppose if we consider the equation x square y equal to 2 plus y, x square y minus 2 equal to 0. Here it is clear that highest power of x is 2. Highest power of x is equal to 2 and the coefficient of x square is y. So, what does it mean? Y equal to 0 is an asymptote, and highest power of y is 1 and the coefficient of y is x square minus 1 equal to x minus 1 into x plus 1.
So, there in the equation, if we take y common, we get y into x square minus 1 is equal to 2. So, that gives us coefficient of y as x square minus 1. We make it equal to 0.
Yes, sir.
Solve, we get x equal to plus or minus 1. Those give us asymptote.
A plus b into a minus b, that is x is equal to plus or minus. Very correct, sir.
And there are, as we discussed earlier, there are some other asymptotes called oblique asymptotes. See, just let us consider one small example. Slide please. Consider the curve given by the equation y square is equal to x square into x plus a by x minus a. So, what does it mean here? Y square into x minus a equal to x square into x plus a. So, the coefficient of highest degree term in x is the coefficient is x cube. The coefficient of x cube is 1. So, it is a constant. So, what does it mean? Highest factor coefficient is constant means it cannot have horizontal asymptotes. So,
there is no y term. So, y equal to something cannot be an asymptote. So,
and here the coefficient of y square is x minus a and x equal to a is the vertical asymptote. Suppose if I put the equation y is equal to mx plus c in the given equation, it matters a lot. After simplification, we get the coefficient of x cube as m square minus 1, which is equal to m equal to plus or minus 1, and substituting here m equal to 1, we are getting y is equal to x plus a or y equal to minus x minus a. So, this kind of asymptotes are called oblique asymptotes, and we discuss how to find the oblique asymptotes. As you said, it is oblique asymptote is the distance pm, that means distance pxy is any point. The perpendicular distance from point to the line y is equal to mx plus c is not finite. So, then we are calling it as oblique asymptote. So, by imposing these conditions, we will find the oblique asymptotes. So, here we take the general equation of oblique asymptote as y is equal to mx plus c. That means m not equal to 0 and the perpendicular distance of the point pxy on this curve is given by Pm equal to y minus mx minus c by square root of 1 plus m square. Now, since m not equal to 0, p can be at infinity on the curve only when x tends to infinity. Thus, as x tends to infinity, our Pm tends to 0. This means your y minus mx minus c, that means limit x tends to infinity, y minus mx minus c is 0, or c is equal to limit x tends to infinity y minus mx, or by simplifying we are getting limit x tends to infinity y by x minus m is equal to limit x tends to infinity y minus mx by x, or by splitting we get c into 0 equal to 0.
In fact, with the help of this equation, m becomes limit y by x as x goes to infinity. So, if we are given an equation, if it is a polynomial equation in x and y, then we look at the limit of y by x as x goes to infinity. Then if this limit is zero, is a non-zero, a real number, then that is m. That is the slope of the oblique asymptote. Then to calculate c, we go for limit y minus mx. Limit y minus mx. So,
limit x tends
and we know the value of m, so we go for the limit of y minus mx. If for example m is 1, limit of y minus mx is limit of y minus x. For this y minus x, we make use of the given equation and we substitute the value of y minus x in terms of the given equation and calculate the limit of y minus x. And if this limit is a real number, that gives us c. So, once we know m and c, we have the oblique asymptote determined, that is y equal to mx plus c. So, whenever these two m and c exist finitely, means whenever they are real numbers, like as limits existing finitely, then we get oblique asymptotes.
Now, as an attempt made to find one oblique asymptote for the curve x cube minus y cube, slide please, x cube minus y cube equal to 3axy for an oblique asymptote, we will write it as by dividing with xy, we get 1 minus y cube by x cube minus 3y by x into 1 by x. After finding limit, I got it as 1.
In fact, you are finding the limit of y by x. You are calling it m. So, limit of y by x is m, and limit of y cube by x cube becomes m cube.
Now, we can write that x cube minus y cube as x minus y times x square plus xy plus y square, which is equal to 3x. Equal to 3xy. From that, I will get the value of c. We know that c is limit x tends to infinity y minus x. So, for that I found out, and I got the value of c as minus 1 after this simplification. Hence, the required asymptote for the curve x cube.
In fact, you are calculating limit y minus mx because m is 1.
M is 1, y minus
x become y minus x, and so you are calculating limit y minus mx, and that is c.
Yes, sir. And so y is equal to mx minus 1. That is the value you are substituting. That. Tell me.
Now, the important point is step 8. So far, now very important one is called to find the singular points. So, how to define the singular points? If k branches of a curve passes through a point P of the curve f of xy equal to 0 and k greater than 1, then P is said to be a singular point or multiple point of order k. Singular points of order 2 are known as double points. For example, look at these curves here. You were discussing about the curve circle equation x square plus y square is equal to r square. Here y is equal to square root of r square minus x square, or y is equal to minus.
In fact, we have x square plus y square equal to r square. That gives y square equal to r square minus x square. Therefore, y is plus or minus square root of r square minus x square. So, it is double valued.
Double value.
Non-negative or negative. So,
we
to
get
make it a function, we have to take two parts. So, they are either in the upper half plane or the
lower half plane.
Because the curve, it is symmetric about origin also.
So,
maybe origin also.
So, this equation x square plus y square r square has got two branches of the graph.
So, it is a double point.
So, at the points A and B we have double points because these branches are meeting.
Actually, depending on the nature of these tangents behavior, we will name the singular points. A double point is known as a node if two tangents at that point are real and distinct. A cusp if two tangents are real and coincident. A conjugate point if the two tangents are imaginary. For this, look at this example.
తెలుగులో మనం ఏమంటామంటే ఒక వక్రానికి ఒకటి కన్నా ఎక్కువ శాఖలు ఉంటాయి,
ఒకటి కంటే ఎక్కువ శాఖలు ఉంటాయి.
ఆ శాఖలు కలిసే చోట ఏమిటి అది అనేక బిందువులు అంటాం, అనేకత్వ బిందువులు పాయింట్స్ అంటాం. అక్కడ ఏమిటి అవి నోడ్నేమో మనం కడుపు అంటాం తెలుగు, అట్లా కస్పునేమో మొన అంటామండి. సో ఏమిటి ఒక ద్వంద్వ బిందువు దగ్గర అంటే రెండు శాఖలు కనుక ఉంటే ఒక బిందువు దగ్గర ఆ వక్రానికి ఆ బిందువు దగ్గర స్పర్శరేఖలు విభిన్నం అయితే అది ఒక నోడ్ అంటే కణుపునిస్తుంది. అది అట్లానే స్పర్శరేఖలు ఒకటే అయిపోతే ఒక మొననిస్తాయి అంటే కస్పునిస్తాయి. ఓకే మేడం,
ఇక్కడ చూడండి ఇంకా కస్పు ఎలా ఉంటుంది. ఎగ్జాంపుల్స్ ఆర్డినరీ డబుల్ పాయింట్స్
చూపిస్తారా?
This one, if you take x equal to cos cube t, y equal to sin cube t, look at this P1, P2, P3, P4.
And here what are the double points? What kind of points are these double points? These are cusps, right?
Yes, cusps.
Yeah.
These
P1,
are cusps.
P2, P3, P4.
Yes.
In fact, P1, P3 they are cusps.
అంటే మనం అనంతమైన రేఖ కాబట్టి మనం వేయలేం కాబట్టి బాణం గుర్తు పెట్టేస్తాం. ఎక్స్ యాక్సిస్ కానీ వై యాక్సిస్ కానీ మనం చేయలేం కాబట్టి పెట్టేస్తాం దాన్ని.
తర్వాత now after discussing about these singular points, and we got an idea after first we discussed about extent of curve, and then symmetry, and then points of discontinuity, and then local maxima, minima, whether curve is increasing or decreasing. After discussing all these points, finally we draw a curve of possible limitations whatever we have discussed. For example, now I would like to discuss about the curve y equal to x cube. So after discussing all these 8 steps, 9th step is to draw a curve. For that, first I am considering one example, y is equal to x cube. Now xy lies on the curve because see y equal to x cube if and only if minus y equal to minus x cube, or you have minus y equal to minus x whole cube, if and only if minus x minus y lies on the curve. This means that the curve is symmetric about origin. Thus, it is sufficient to draw the graph above the x-axis and join it to the portion obtained by rotating it through 180 degrees about the positive x-axis in anti-clockwise direction. And also above x-axis, x is positive. Above x-axis, x is positive. What does it mean? Yes.
Above x-axis, y is positive.
Y is positive. Above x-axis, y is positive. No. So you have x equal to cube root of y because we have taken x equal to y cube, isn't it or not? So you have cube root of y y is equal to x cube. So x is equal to cube root of y must be positive. So that is what does it says? There is no portion of graph in the second quadrant. There is no portion of curve in the second quadrant. So the curve meets the coordinate axis only at the origin. Curve meets the coordinates at only at the origin, and the tangent there is x-axis. And after that we will find as a step 4 we have to find dy by dx. Our dy by dx is 3x square. Dy by dx is 3x square, always derivative of x cube. It is positive. So what does it mean? Curve is increasing. And you
if
have
the derivative is positive, the curve is increasing or raising. The graph is raising.
Graph is rising.
Arohanam antam.
Yes.
So your dy by dx is 0, and
as
your
per the geometrical
d square y by dx square is nothing but 6x, which is also 0 at the point x equal to 0 and y equal to 0.
And in fact the second derivative is 6x and it is positive in the first quadrant.
Yes.
So the curve is convex.
Yes,
convex. Curve is convex. This implies that there are no extreme points and 0 0 is the point of inflection here. The graph has no asymptotes parallel to x-axis. Why? Because as x tends to plus or minus infinity, we have y is also plus or minus infinity, but not 0. So that is the reason it has no asymptotes parallel to x-axis.
So m is becoming infinity.
Yes. Here
so
if
we
you
want m the finite number. If that is the case, then we may have oblique asymptotes.
Yes, oblique asymptotes.
Yes. If you are finding
asamanya rekhalu.
Limit x tends to infinity, y by x is nothing but x square.
మనం అనంత స్పర్శ
దీన్ని తిరియక అనంత స్పర్శ రేఖలు అంటాం వీటిని.
So the curve is a single branch and has no singular points also. It has no singular points.
Okay.
So if you want to move on, other curve is also
one
there.
more point, madam. So once we draw the graph in the first quadrant, we have to rotate it by 180 degrees.
180 degrees, so
to
that
get the graph in
Yeah.
the third quadrant.
Third quadrant.
These two parts together will give us the graph of y equal
y
to
equal
x.
to x cube.
ఈ 180 డిగ్రీ గ్రాఫ్లో మనం పాజిటివ్ వాల్యూస్ వస్తే ఫస్ట్ నెగిటివ్ వాల్యూస్ వస్తే థర్డ్ గ్రాఫ్లో వస్తే మనం కనుక ఫోల్డ్ చేసినట్టయితే
Yes.
అది ఎగ్జాక్ట్గా వస్తుంది,
సూపర్ ఇంపోజ్ అవుతుంది.
సూపర్ ఇంపోజ్ అవుతుంది. అంటే మైనస్ వాల్యూస్ వస్తే థర్డ్ క్వాడ్రంట్లో ఉంటుంది, పాజిటివ్ వాల్యూస్ వస్తే ఫస్ట్ క్వాడ్రంట్లో ఉంటుంది. అంటే దాని tan θ ఆఫ్ వాల్యూస్లో బట్టి కంటిన్యూ.
Next, shall we discuss one more example
Yes.
of tracing
And
the
shall we
curve?
move to parametric equations?
Yes, yes, sir. Yes, sir.
Madam?
Yeah.
Let's move to parametric form of equations.
Yes. Next, we move on to tracing a parametric equation. The set of points xy given by f of t comma g of t described by these equations when t varies an interval I from a curve, I form a curve called a parametric curve, which is given by x equal to f of t, y equal to g of t. These are called the parametric equations. We know that y is equal to x equal to 80 square, y equal to 280, or the parametric equation of the parabola y square equal to 2ax.
If y is 280, y square is 4a square t square.
Yeah.
That is 4a into 80 square. If 80 square is x, it is 4ax.
4ax.
So x equal to 280, x
X
equal to
equal
80
to
square,
y is equal to 280.
Those are the parametric form of equations of a parabola.
Parabola.
Y square is equal to 4ax. Now, in this also we will study the symmetry and same rule. How we find the symmetry? The curve will be symmetric about x axis. If we replace t by minus t, x will be remained unchanged and y changes sign, then the curve is symmetric about x axis. And about y axis, replace t by minus t, x changes the sign and y remains unchanged, then the curve is symmetric about y axis. And about origin, we replace t by minus t, both x and y change the sign, we say that curve is symmetric about origin. And how to find point of intersection? If for some values of t, both x and y are 0, curve passes through the origin. And we will find as usual x intercept and y intercept, and we find asymptotes. We know that dy by dx is dy by dt by dx by dt. We will find parametric differentiation.
Yes.
We perform parametric differentiation and we find dy by dx, and we find the regions of absence also. How you find tangents? Find dy by dx given by dy by dx, dy by dt divided by dx by dt, and then we will form the table of values of t x y dy by dx, and then draw curves like this. Suppose if you
So
take
one more point, madam.
yeah,
So we will find dx by dt and dy by dt,
dt
and
divided-
then with the help of them we can find dy by dx.
dx.
Yes, sir.
Yes.
And to find d square y by dx square.
Yes.
So dy by dx can be differentiated with respect to x,
And-
and you find dx by dt and multiply them.
Yes, sir.
Yes.
You get d square y
By
by
dx
dx
square.
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 In the parametric equation, the y should be differentiated as the numerator, x is the denominator of the second derivation, d by dx of y1, and the denominator of the x of the second one only one time we are derivating. We can substitute the second derivation will become.
Yes. Now, these are the some examples, slide please, examples of some parametric curves, x equal to a cos cube theta and y is equal to a sin cube theta. Because lack of time, we are showing only the visuals to
In
discuss.
fact, in fact, here theta is in radians, it is a
Yes.
real number.
Yeah.
In place of theta, we can as well take t.
Yes,
So these two equations are parametric form of equation.
Yes, sir.
parametric
It is a
form
parametric
equations.
equations.
And
And
another
xy are
one,
rectangular coordinates. They
Yes.
are Cartesian coordinates.
coordinates. Here one more curve is given by x equal to a into theta plus sin theta, y is equal to a into 1 plus cos theta. The curve goes like this.
Yes, the value substituting, we are
Yes.
point substituting, the curve will becomes that type of
Yes.
given slide in that given the
Yeah.
we shown that.
In fact, that's the famous curve, cycloid.
Cycloid, yes.
Yeah. Cycloid is actually can be defined as follows. If you take a circle, you fix a point on the circle and you move circle along a line. So when you move circle along a line, the locus of that fixed point is called cycloid. Okay, you are fixing a point on the circle and then you are moving the circle along a line. Okay, and then you look at the locus of that fixed point. You will be seeing how that fixed point is moving.
Yes.
So that locus will be giving you cycloid.
Yes.
This is a very famous curve, and it has many applications. In fact, in the gearbox, the gear wheels, the shape of the gears will be in the form of cycloid.
Cycloids,
And also, a cycloid is the curve which gives us the quickest descent. In the sense, if we take 2 points A and B, which are not at the same height, okay, and the point is, and if you are trying to move a ball, drop a ball from here to here, A to B, and what should be the path of this ball, so that it moves from A to B in quickest descent, right? What should be the shape of the path? So that becomes cycloid.
Yes.
Okay? It is not usually, when you are given 2 points, you expect a straight line to be the short, it would be giving quickest descent, but it is not. Straight line does not give us the quickest distance.
Yes, sir.
Yes.
In fact, in cycling races also you may see the cycling track will be, if a cyclist wants to move fast, then he will be going up the track and he will be moving down.
Yes.
He will try to move his cycle in the path along a cycloid, so to get the quickest distance, quickest descent. Okay, so even in a cycle also you may observe. In a bicycle, in flywheel you can observe
Yes.
you will have cycloid grooving will be there.
Yes, sir.
Yes.
Okay, even in clocks also this mechanism is used.
Grooving is there.
Yes.
Okay.
Shall we move on to polar curve, sir? You give introduction to polar curve, R and theta. For example,
if you take a point in the xy plane, if its coordinates are a comma b, if its Cartesian coordinates are a comma b, we drop a perpendicular from p, the a comma b, to the x-axis, right? And we join p with the origin. If origin is O, OP is the line segment joining them. In fact, OP gives the distance of the point P from the origin, that we call small r. Okay, and the angle OP makes with the positive x-axis in the positive direction. By positive direction we mean the anti-clockwise direction.
Yes, sir.
So that is theta. If that is theta, we get that A equal to
X equal to R cos theta.
Usually we denote P by X
Yes,
and Y.
sir.
We get X equal to R cos theta,
And y is equal to R sin theta. As x square plus y square is equal to r square, we
then
get
r is equal to under root of a square plus b square.
Yes.
అంటే ఇక్కడ p a కామా b అనేది ద్వితలంలో ఉంటుంది. నేను తెలుగు మీడియం స్టూడెంట్స్ కి ద్విపరిమాణ xy తలంలో ఉంటుంది కాబట్టి r is equal to మనం వాళ్ళకి
ఇక్కడ
తెలియడానికి
ప్లేన్ లో కూడా మనం r theta తీసుకుంటాం.
So we have relationship between Cartesian coordinates x comma y and the polar coordinates r comma theta. So x equal to r cos theta and y equal to r sin theta. These two equations connect Cartesian coordinates with polar coordinates. And
Similarly,
we
if
can
you
do
take ellipse also, you get a cos theta and b sin theta. Ellipse, x square by a square plus y square by b square is 1. We can have polar coordinates.
So if you know r and theta, you can calculate x and y with the help of the equations x equal to r cos theta and y equal to r sin theta. And if you know x and y, then also you can calculate r and theta.
Yes,
R becomes square root of x square plus y square, and theta becomes tan inverse y by x.
Y by x.
And during calculation of tan theta, we should be careful.
Yes,
Yes.
sir.
Can you tell something about that?
Yeah, polar curves, also how to check symmetry. As usual, our curve tracing will be following the same directions, as you told 9 steps. Here also we will see the symmetry.
But actually, I want to talk about that finding theta.
Yeah.
Theta is tan inverse y by x.
Yes.
For example, if our point is -1 comma -1, if the ordered pair is -1 in xy plane in the Cartesian coordinates, then its theta is tan inverse -1 by 1. That is
Pi minus
tan inverse 1.
Tan inverse 1.
But we don't take pi by 4.
Yes.
We take 3 pi by 4.
3 pi by 4 we take pi
because
minus
the
pi by
location of the
4.
point -1 is important in
Yes.
determining theta.
Yes. Here symmetry, a polar curve about the initial, a polar curve is symmetric about the initial line if we replace theta by minus theta, no change in the equation. And we say that it is symmetric about pole if replace r by minus r, no change in the equation. And about the line perpendicular to the initial line means y axis, if you replace theta by minus theta and r by r, Otherwise, we can replace theta by pi minus theta also. There is no change in the equation. In such a case, we say that the curve is symmetric about line, initial line. And again, it is symmetric about pole. If certain value of theta are equal to 0, then we say that curve passes through the pole.
Madam,
And
what is pole, madam? It is the origin, right?
Yes, origin, origin. And the tangents at pole, we equate r equal to 0 and solve for theta. The lines theta equal to constant are the tangents at the pole. Now we prepare table of values of r and theta, and we will find angle between tangent and radius vector. Suppose if phi is an angle between tangent and radius vector, then we know that tan phi is equal to r into dr by d theta. That means phi equal to 0, the tangent and radius vector coincides, and if phi equal to pi by 2, tangent and radius vector are perpendicular. And we will find the region of absence, and we discuss about Rose curves. Finally, just one point, Rose curves. A Rose curve is a graph that is produced from a polar equation in the form of r equal to a sin theta or r equal to a cos n theta, where a not equal to 0 and n is integer. They are called Rose curves because the loops that are formed resemble petals. The number of petals that are present will depend on the value of n. The value of n will determine the length of the petals. If n is even integer, then the rose will have 2n petals. If n is odd integer, rose will have n petals. These are the examples for petal curves.
Right.
Thank you.
So, and this r equal to a sin to theta, a is a positive number.
R is
then
a
it has
sin
two
and
branches.
theta. Yes, 2 branches.
Then it has 2 branches. So you will have you will have double points there.
Yes.
Okay.
ఈరోజు మనం కర్వ్ ట్రేసింగ్ అంటే వక్ర నిర్మితి గురించి నేర్చుకున్నాం. అసలు ఈ వక్ర నిర్మితి అంటే ఏంటి, దానిలో ఉన్నటువంటి రేంజ్ ఏంటి, పరామితీయ సమీకరణాలు అంటే ఏంటి, అందులో ఉన్న 9 స్టెప్స్ ఏంటి, డిఫరెన్షియేషను, అజంప్టోట్స్ అంటే అనంత స్పర్శరేఖలు, తిర్యకనంత స్పర్శరేఖలు, సింగులర్ పాయింట్స్, పరామితీయ సమీకరణం అంటే ఎక్స్ ఇస్తారు, వై ఇస్తారు, డివై బై డిఎక్స్ ఎలా కనుక్కుంటాం, సెకండ్ డిఫరెన్షియేషన్ ఎలా కనుక్కుంటాం, దాని పాయింట్ గీస్తే ఇలా ఏ రకంగా ఆ కర్వ్ వస్తుంది, పాయింట్స్ వస్తాయి, సైక్లాయిడ్స్, డివై బై డిఎక్స్, పోలార్ కోఆర్డినేట్స్, పోలార్ ఫార్మ్స్, ఇవన్నీ మనం ఆల్రెడీ నేర్చుకున్నాం. ఇక్కడ మా సబ్జెక్ట్ ఎక్స్పర్ట్స్ ఇద్దరు కూడా విశ్లేషణాత్మకంగా మీకు పీపీటీ రూపంలో కూడా చెప్పడం జరిగింది. అదేవిధంగా దీనిలో ఇంకేమైనా మీకు సందేహాలుగా ఉన్నట్లయితే మీ దగ్గరలో ఉన్న అధ్యయన కేంద్రంలో ఉన్న కౌన్సిలర్ దగ్గరికి కానీ వెళ్ళండి, మరియు యూనివర్సిటీ ప్రధాన కార్యాలయంలో ఉన్నటువంటి గణితశాస్త్ర విభాగంలో అయినటువంటి ఆచార్యులు శ్రీనివాస్ గారిని కానీ అక్కడ సంప్రదిస్తే మీకు మరిన్ని ఆ యొక్క డాక్టర్ శ్రీదేవి గారిని, డాక్టర్ శ్రీనివాస్ గారిని ఇద్దరిని సంప్రదిస్తే వాళ్ళకు మీ యొక్క అనుమానాలు నివృత్తి చేస్తారు. అంటే ఈ రకమైనటువంటి ఈ కర్వ్ ట్రేసింగ్లో మనం ఇవి నేర్చుకుంటే మనం సక్సెస్ఫుల్ మార్క్సే కాదు, దానికి సంబంధించిన డీటెయిల్ కూడా నేర్చుకుంటాం. ఈ కార్యక్రమంలో ఇంత విశ్లేషణాత్మకమైనటువంటి వివరణ అందించినటువంటి ఆచార్య వేదనభట్ల శ్రీనివాస్ గారికి, డాక్టర్ విజయలక్ష్మి గారికి నేను ప్రత్యేక ధన్యవాదాలు తెలియజేసుకుంటూ ఈ కార్యక్రమాన్ని ముగిస్తున్నాము. థ్యాంక్ యూ.